Hi guys, welcome again to our MPLAB XC8 tutorials for absolute beginners series. This is tutorial 98, interfacing ENC28J60 Ethernet controller with PIC microcontroller. Ethernet is the leading wired standard for networking as it enables to connect a very large number of computers, microcontrollers, and other computer-based equipment to one another. As we have learned from the previous tutorial, with just a switch or a router, many Ethernet connected devices can be controlled from remote locations. This is the Ethernet cable that can be used to connect different Ethernet devices. This is a Cat6 Ethernet cable with RJ45 connectors. There are microcontrollers with built-in Ethernet peripherals like the PIC ENC28J60. This PIC has an integrated 10 megabit per second Ethernet communication peripheral. These are some of its features. It got an integrated MAC address. It's fully compatible with 101 gig base T networks, and is also compatible with the IEEE 802.3 standard. But the problem, many microcontrollers don't have a built-in Ethernet controller. That's why in this project, we are going to use a serial Ethernet chip that can be easily used by any microcontroller with an SPI interface to provide Ethernet capability to this application. We are going to use the ENC28J60. This is a popular 28-pin standalone Ethernet controller with SPI interface. These are some of the features of this Ethernet controller. It's compatible with the IEEE 802.3 standard, fully compatible with 101 gig base T networks. It supports full and half duplex mode. The SPI interface with clock speed up to 20 MHz. Its operating voltage is 3.1 volt to 3.6 volt, and it's got some 5 volt tolerant input. With internet in mind, one can think of many applications like this web-based control and monitoring system. A user from a remote location can control devices connected to the PIC microcontroller, like anything connected to this relay. The user can also switch on and off anything connected to the pin of the PIC microcontroller. The user can also get the status of any devices like sensors connected to the PIC microcontroller, like in this demonstration, this DHT11 temperature and humidity sensor, or this switch. You can also monitor and control the access of an area from a remote location. One can also think about some environmental monitoring. Some environmental sensors like humidity, temperature, light, pressure, altitude, and many other sensors can be connected to a PIC microcontroller and installed unattended in remote locations, feeding data online to a control and monitoring center. This can also be used in home automation. One can turn devices inside the house like light bulb on and off from a remote location, even from a handheld smartphone connected to internet. This is a typical connection of the ENC28J60 to a PIC microcontroller. The interface between the ENC28J60 and the microcontroller is based on SPI bus. The SI, SO, and clock pins can be connected to SPI pins of the PIC microcontroller. The chip select pin can be connected to an input-output pin of the PIC microcontroller. And the interrupt pin can also be connected to any interrupt pin of the PIC microcontroller. The RJ45 connector can be connected to TP in and TP out of the ENC28J60 via an Ethernet transformer. Two LEDs can be used to provide visual indication of the link and activity of the Ethernet line. The ENC28J60 Ethernet controller is designed to operate at 25 MHz with a crystal connected to oscillator 2 and oscillator 1. Depending on the microcontroller used, the SPI pins may be located to different pins. In this example, the serial clock of the PIC microcontroller is on RC3, should be connected to serial clock of the ENC28J60. The SI pin should be connected to SPI SDO pin. The SO pin should be connected to SDI pin of the PIC microcontroller, and the chip select pin can be connected to the input-output pin of the PIC microcontroller. In this case, it was connected to RC1. The ENC28J60 is designed to operate with 3.3 volt. If your PIC microcontroller also operates with 3.3 volt, then you're not going to have a problem. All these pins can be connected directly to the PIC microcontroller. However, if your PIC microcontroller operates at 5 volt, the chip select pin, the clock pin, and the SI pin can be connected directly to the PIC microcontroller because they are 5 volt tolerant pins. But the SO, the interrupt pin, must be driven by 3.3 volt. A unidirectional level translator will be necessary. You can use an economical 74HCT08 or a 74ACT125 or any other 5 volt CMOS chips with TTL level input buffers may be used to provide the necessary level shifting. These two LEDs provide visual indication of the link and activity on the Ethernet line. These LED A and LED B pins have maximum current capacity of 12 milliamp, so current limiting series resistors should be used. The internal analog circuitry of this module requires that an external 2.32K resistor be connected to this pin RBIAS to ground. The resistor influences the TP out plus and the TP out minus signal amplitude. This resistor should be placed as close as possible to this module to prevent noise, and it is recommended to use a surface mount resistor. Some of the device digital logic operate at a nominal 2.5 volt. An on-chip voltage regulator is incorporated to generate this voltage. The only external component that is required is a filtering capacitor connected to VCAP and ground. This capacitor must have low equivalent series resistance with a typical value of 10 microfarad and a minimum value of 1 microfarad. The RJ45 connector can be connected to TP out plus, TP out minus, TP in plus and TP in minus via a network transformer. This is the list of the Ethernet chip pins and their description. VSS should be connected to ground. VSSPL, VSSTX, VSSRX, and VSS oscillator can be connected to ground. VDD-PLL, VDD-TX, VDD-RX, and VDD oscillator can be connected to positive 3.3 volt supply. To make the design of Ethernet applications easy, there are ready-made boards that include the ENC28J60 controller, the voltage translation chip, and the RJ45 connector, like Microchip serial Ethernet board. This is a small board that plugs in directly to port C of the EasyPIC development board via a 10-way IDC plug, simplifying the development of embedded Ethernet project. You can also use the ETH click, which can be used in any development board with microbus. In this example, we're going to use the ETH click with Curiosity development board. We're not going to go through all the theories of this chip. You can read the data sheet. In this tutorial, we're going to use Microchip TCPIP Light stack with MPLAB code configurator to control our chip. We can learn more about this Microchip TCP Light stack from the application note 1921. From Microchip website, go to MCC. Under current download, you can download the TCPIP Light stack and install it in your current MPLAB code configurator. Let us open the release note of the TCPIP Light stack. These are the requirements. You must use at least MPLAB XIDE 3.61 or later. The XC8 compiler must be 1.42 or later. The MCC must be 3.36 or later. You must also install the PIC10, PIC12, PIC16, and PIC18 MCU. From this current download site, you must also install the foundation services from the same current download site. We can go through this release note. It says these are the minimum flash requirement for use with your TCP/IP Light stack. So any PIC microcontroller supported by MCC and with SPI bus must have at least more or 8 kilobyte of flash memory if you're gonna use only UDP. But if you're gonna use only TCP, it must have more or 16 kilobyte. And if you're gonna use UDP and TCP, it must also have more or 16 kilobyte. And if you're gonna use UDP and NTP or DNS or TFTP or LLDP, it must have more than 16 kilobyte. We have already installed our TCPIP Light stack library. So let us start a new project. It's gonna be a standalone project. In this example, we're gonna use the Curiosity development board with PIC 16F 1834-6. Next, select your hardware tool. We're gonna use the Curiosity starter kit PKOB. Next, gonna use the latest compiler. Next, we're gonna name this project ENC28J60. Finish. Click on MCC. We're gonna start with the system module to set our internal oscillator. We're gonna use this default clock of 1 MHz. If you're using the Curiosity development board, don't forget to tick the low voltage programming enable. The Microchip TCPIP Light stack is implemented in a configurable and modular way, allowing users to include only the intended features or functionalities to the application. In this example, we're not gonna do much. We're just gonna configure our Ethernet board to communicate with TCP, give it an IP address and be able to ping it so that we can know it's working. So the next thing, we're gonna configure our IP address. Under the libraries, double click TCPIP Light. We're gonna disable the UDP. This is used to send or receive UDP packet. In this example, we are going to use TCP, so we're gonna tick the TCP. We're gonna disable the DHCP because we're gonna use a static IP address. The IP version 4 should be ticked. The Internet Control Message Protocol should be checked. We can also check the option to generate the echo response and the port unreachable messages. The ping command uses this ICMP protocol. Any TCP/IP packet with invalid port number will respond with ICMP port unreachable message if this ICMP port unreachable option is selected, else the TCP packet will just be discarded. We're gonna check the address resolution protocol. This refers to the maximum size of the ARP table. The default table size of 8 is gonna be used. We're not gonna check the trivial file transfer protocol, the network time protocol, the domain name system protocol, and the link layer discovery protocol. There's nothing to configure in the TCP option, but in the IP version 4, you have to configure the IP address. We're gonna give our Curiosity board the IP address of 192.168.8.5, and the default gateway is gonna be .8.1. Remember, this has to be within the same range of your local network and your PC. If you don't know the IP address of your PC, you can use the ipconfig command, cmd ipconfig. We are connected to wireless LAN. This is our computer IP address is 192.168.8.101, which is in the same range as the IP address we are giving to our Curiosity board. And our default gateway is 192.168.8.1, so we should be able to communicate. The default subnet mask is going to be 255.255.55.0. The TCPIP Light module requires the Ethernet MAC library and timer 1 module. The TCPIP stack needs a background task called periodically by the user in order to handle asynchronous events like managing a timeout, checking the status for the Ethernet controller, and passing the receive buffers. So we're gonna include the Ethernet MAC library. Under the Ethernet, double-click MAC. We're gonna select the ENC28J60. And you have to select your SPI bus. We're gonna use MSSP1 because the Curiosity Development Board DM164137 support the MSSP1 SPI module interface on the RJ35 connector. So the next thing, we're gonna configure timer 1 under the peripherals. Timer 1. So we're gonna enable the timer, update the timer period to 250 milliseconds. Enable the timer interrupt and update the callback function rate to 4 to generate a 1 second period. This feature is required to configure the device with 1 second tick of system clock. Let us configure our SPI module. Under MSSP, select MSSP1, select SPI master, input data sampled at the end. Clock polarity is gonna remain at idle low and active high, and clock edge active to idle. We're gonna generate the SPI clock at 250 kHz. And lastly, we'll need to configure our input-output pins. Click on pin module. We're gonna set the MAC chip select pin of the ENC28J60 controller to output RC6. The clock is gonna be input-output RB6. We're gonna set SDI1 to input RB4 and SDO1 to output RC7. And that's all, guys. Click on generate, save, go to our files. These are the files that were generated by MCC. These are the header files. These are the source files. Open the main.c. We have to enable the global and the peripheral interrupt. Peripheral interrupt. And that's all, guys. In the while one loop, we're just gonna call one function, network manage. This function polls the Ethernet controller for new packets and processes them. And that's all, guys, for this tutorial. With this function, we're gonna be able to send a PIC command. This Ethernet controller is gonna process it. Then we should be able to ping our board. Build the project. The build was successful, no errors. If you want to simulate the ENC28J60 Ethernet controller with Proteus, these are the steps to follow. Right-click the ENC28J60, edit properties. This is the host adapter number or IP address. So basically this is gonna be our PC IP address. Right-click, open Network and Sharing Center, change adapter settings, Ethernet. This is our Ethernet card. Properties, protocol version 4, You can see this is our PC IP address. You can click on help to learn more how to simulate this chip. The Ethernet physical interface models provide access to the local network from the simulated schematic. The simulated network controller works through any existing Ethernet network card connected to the local network. If you want to learn more how to set up your card, you can read this section. Or if you are using the VMware software, you can also go through these steps how to set up your network card. But you must always remember, before running the simulation, you must install first the WinPCAP software. You must download the latest version of WinPCAP auto-installer, including the DLL libraries from their website, which is www.winpcap.org. These are the steps how to install. Without this software, your simulation is not gonna run. Okay, close. Okay. In this tutorial, we're not gonna simulate, we're gonna use the Curiosity development board. Let us connect the Curiosity board to our computer. Let us make and program the device. Curiosity, we're gonna upload our X file to the Curiosity board. Okay. Okay, this is our simple setup. The Curiosity board is connected with a USB cable to our programming computer, and the ETH click is plugged into the Curiosity development board. There is an Ethernet cable Cat6 connected to our router. Let us ping our board so that we know that it's working. We gave it an IP address of 192.168.8.5, ping 192.168.8.5. Okay, so we are able to ping our board, so we know that it's connected and is responding to Ethernet packet. That's all, guys, for this tutorial. In the next tutorials, we're gonna do more Ethernet project, like controlling devices connecting to a PIC microcontroller from a web browser or from a C# based application. Thank you guys for watching this tutorial. If you found this tutorial helpful, please like it, leave a message, and don't forget to subscribe to this YouTube channel to be notified when we upload new tutorials. Thank you.